All right, ladies and gentlemen, today what we're going to talk about is something known as linear regression, and we're going to talk about scatter plots. All right. Now, a couple things you need to have. Hopefully you already have your notes already printed out, but you also need to pull up your calculator. All right. Pull up your calculator. It should be the TI version. I've got something like this here. You guys can look at. I'm just going to kind of clear that out so you guys can look at it. But just have your calculator out there too. If you've got one at home that you're using, just use that one. It's up to you, but you're going to need that also today. So, to explain linear regression and the line of best fit, we're actually going to use it with the problem. It's going to be the easiest way to do this. Now, for you guys, what you guys have done is you have this data on here. All right. The year for this, and again, we're talking about a population of wolves. You guys can read through that. The year is going to be your independent or your X value. The number of wolves is your dependent, your Y value. Okay. Now, it says here, prediction has been made and the information given for the population of wolves in year 2010. There you go. So this one right here, this is not on there, but this is going to be your prediction. Okay. So after that, it says make a scatter plot. Okay. So what you're going to do is basically take this data and you're going to plot it on here. If you need to pause right now to get it done, pause, get that written on there. All right. So from there, what we're going to do is we're going to create a line of best fit. So what you're going to do is you're going to try to create a line that has as many points as possible on that line that best represents this set of data. So something that looks on the lines of this. That would be what I would call the line of best fit for that data. Now, as I look at that, I should notice that there's one point way the heck off there. Well, that point that we're talking about is actually our prediction, the 2010 and the 340. All right. So if we're looking for, well, we notice that point has nothing to do with, or even close to our data. So if we have an outlier, a point that does not represent these points, and this happens in experiments all the time, sometimes there's errors. You don't have to count that point, right? Because it's not going to help us represent our data. Okay. So we're going to use this to try to represent the points that we've graphed on here. And what we're going to do is we're going to write an equation that best represents this. And this is what the regression part does for us. So what you're going to do is you're going to go to your graphing calculator. All right, so with the graphing calculator, what I want you guys to do is I want you to find the stat key. Stat key is right below the delete key, right here. You're going to press stat. Once you press stat, you're going to see what we want to do next is we want to edit. What we're going to do is we're going to edit these two columns. The L1 column is going to stand for your X coordinate. The L2 column is going to stand for your Y coordinate. What I want you guys to do, and which I've already done, is I want you to put these points into L1 and L2. All X coordinates in L1, all Y coordinates in L2. Make sure that they stay in the same row. Okay? So at the very end, you should have 2008 and 2020. We're not using the 2010, our prediction, because it doesn't match. It's an outlier. Okay? If you need to pause, plug this stuff in, do so. All right, so now what we're going to do is we're actually going to, with this data, we are going to take a look at it in our window. Okay? Now, what you want to do is we're going to try to look at it, because right now if you try to press graph, it doesn't show up. And there's a couple reasons for that, and I'm going to show you both. The first thing is we're going to change our window. Now if you notice, we're basically in the first quadrant, so I'm going to use our X minimum. I'm going to use a 0 to describe that. Okay? The maximum value, what was our largest number that we had for that? Well, it was what, 2002? So what I'm going to do is I'm going to use something a little bit bigger than that. Or 2008, sorry. So I'm going to use 2020 for my X value. Okay? Now, with that in mind, our lowest value of Y, lowest value of X, I messed that up. I'm sorry, guys, we're going back. Lowest value of X, that was what, 1992? So I'm going to use 1990. All right, we're making this a little bit smaller. I apologize. So then, lowest value of Y was what, about 10. So I'm actually going to keep it at 0. So I'm going to have the X, well, the the x-axis on there. All right, and then the max value was, what was that, about 100 and, what was it? Let me take a look. About 220. So I'm going to have something a little bit bigger than that, so I'm going to use, say, about 250. Oops. Sorry, guys. Still getting used to using this thing, too. Whoops, sorry. Went back too far. Edit. Now we go stat. Oh, window. Sorry, we're at window. Let me go back. Alright, so we had y minimum of 0. And then y max I'm going to use about 250. Yep, so that's 225. Alright, there we go. So if I look at the graph, I notice I don't see anything. And there's a reason for that. You don't see anything because we have to actually do something called turn on stat plot. Stat plot is going to be second, and the y is equal to button. This right here, stat plot 1, has to be turned on. It's not hard, just press enter. Press enter to highlight the on button. Right? And then you can press graph again. Hey, there's your points. Okay? So we've got those on there. And so this is kind of what it looks like. Well, if we want to create a line that best represents those, let's press stat, go to calculate. Right? We're going to go down to something known as linear regression. That is going to be number 4. Oops. There we go. Number 4, linear regression. Now, you see the ax plus b. For some reason on this calculator, it doesn't use m for the slope. It uses a. Don't ask me why. It just does. Okay? You're going to press enter. Now you're going to keep pressing enter until you get down to calculate. And then once you get to calculate, press it one more time. Your calculator is going to think. And then this is going to show up. Now what this is this represents the equation. The a is going to represent your slope, so about 13.7. The b is at negative 20, or was that, yeah, 27,316.1. Now, I would not want to figure that out by myself, all right? So that's why we have this linear regression. So what you can do is take that, plug that information in, and now, at this point, you now have an equation, okay? All right, so with that equation, we can make predictions, okay? So obviously our prediction stunk. So let's make a prediction, all right, using the equation from part C to see what the population of wolves would be in 2010. So 13.7 times 2010 minus the 27,316.1 gives us about 221 wolves, okay? So that is linear regression. Let's try another one. Well, actually, let's go on to this part. So, part of our notes. So, the most accurate linear line showing the relationship between two sets of data is called a line of best fit. So, in other words, drawing a line that best represents the data. The graphing calculator computes the equation of a line of best fit using a method known as linear regression. Now, the graphing calculator also gives you a correlation coefficient. Now, we're going to talk about that here in a second. It's known as your R value, which will tell you how closely the equation models the data. Okay? When the data points cluster around a line, there is a strong correlation between the line and the data. So the closer that the R value is to -1, it is close to a negative correlation. The closer that is to a +1, the more closely the data represents the line of best fit. The closer it is to -1, more of a negative correlation it is. The closer it is to +1 is a better fit for a positive slope. -1, think of negative slope. +1, think of positive slope. Anything near 0 or anywhere in that area basically means you've got a bunch of data that doesn't make any sense. All right, we're going to talk about that here in a second. All right, let's go back to our calculator. So if we go back to the calculator, notice you just have this. Well, there's something we want to turn on. We want to turn on that correlation coefficient, that R value. So here's what I want you guys to do. I want you to press the second button. Once you press the second button, I want you to press catalog. Now in catalog, there's all kinds of different, basically, programs that we have that you can use, but the ones that we're going to talk about is known as diagnostics on. So you're going to have to go all the way down on your calculator, and it's going to take a while. It is in alphabetical order. All right, and what we're going to go down to is get down to the D. All right, there we go. So enter for diagnostics on. Press enter again to actually turn it on. Maybe. There you go. All right, so now I'll show you what happens. Press stat, go to calculate. Number 4, which is linear regression. Go to calculate. Now you'll see these R values down here. The one we care about is the R one, this one here. Basically what you're talking about is anything that's very close to 1, so 0.989 is really close to 1. Tells you you have a very good line of best fit. Okay? So that's kind of what they're talking about when they're talking about the R value. It's almost positive, so it is a positive slope. All right, guys. We're going to go on to the next problem. So as you guys can read here, it says using a graphic calculator, find the equation line that best fits the data given below. On this problem, they want you to use the 80, not the 1980, when you guys are talking about the independent variable for the year. Okay, dependent variable for this one, when we're talking about greeting card sales in billions of dollars, which will be important for us later. Your Y value. Okay, so starting off with going to your calculator, you're gonna take this information, if you need to, and I'll go back here just so you guys can see. So if we go back somewhere in here, whoops, I can quit. There you go. Press stat again. Go to edit. Now in edit, I've already put the information in there. You can pause it right now. But again, X coordinates are going to go into L1, the Y coordinates go into L2. Remember, you're not using 1980, you're using just 80. Okay, so pause it, get all that information in. Alright, so now once you got all the information in, you're going to press stat. Okay. We're going to go to the right to calculate, and then we're going to go down to 4, which is going to be linear regression. Or you just press the number 4, it doesn't matter which one. Press enter, then I just press enter until I get down to calculate it. Calculate, press it one more time, does its job, and now you've got a slope for A, y-intercept for B, and it gives you the R value. Now if you notice, the R value is 0.99. That means it's a very good positive slope in this case. Okay, it just means that it's a very accurate line. Okay, so take that information, the 0.2, and I'm going to write 0.27, right, and then negative 19. So there's my slope and there's my y-intercept. Now I'm going to use 0.27x minus 19.54. Okay, what was the correlation coefficient? Well, you found that, it's right here. Okay, now with the correlation coefficient, you're going to find a lot of times they write that very, very long, so they'll use at least 4 spots. Okay, so what is the meaning of the slope for this situation? So you get a slope of 0.27. Okay, well, what that means is that 0.27 billion increase in dollars each year in sales. In other words, 270 million. Okay, so if we want to predict a sale in 2010, all we're going to do is take that 2010. All right, but we don't put in the number 2010 because we want 80. So 2010 minus 1980 is actually going to look like 110. Okay, so we're going to use 110 for this one. Okay, so 0.27, 110 times 110 minus 19.54 will give us 10.2 billion. That's a lot of money for greeting cards. Okay, all right, we're going to move on. Now, what we're going to do is talk about line of best fit. Okay? Now, when we talk about line of best fit, we're talking about a line that basically best represents the line that we have here. Now, if we look at this, the data are the points that we have on this graph. The blue line is somebody's attempt at making a line of best fit. And as you guys can tell here, this line does not best represent these points. So, what we need to do is basically what we're going to ask you to do to start off with is, can you tell us what we need to change? Well, the slope. The slope of our line, the blue one, and the actual data is wrong. So if it's wrong, how would you change the slope? And when we talk about changing the slope, do we make it flatter? Do we make it steeper? Do we change the slope by positive, negative? What would we do? Well, on this one, this line is too flat. So I would want a steeper line. If I want a steeper line, that means I need to increase the slope. I need to make the number larger. Okay? Now, if I look at this, if I draw a line of best fit here, I'm going to get something that's going to look a lot like that. Okay? Now, if I look at that, I'm going to look at the y-intercept. Well, that y-intercept's pretty darn close. So do I really need to change it? No. Okay? So no change for the y-intercept. Okay? All right, let's look at 8. This one here, if I draw a line of best fit, this is what I want you guys to do. If you want to pause it and do it now, you can. I'm going to draw a line that looks a little bit like that. Okay? Yeah, it's pretty close. Okay? That line better represents those points. Well, if I look at the slope, if I kind of look at these two lines, well, they look like they're basically parallel. Okay? So am I going to do anything to the slope? No. I'm going to leave it the same. What I do want to do when I look at something like this is I want to take the y-intercept for this one, and this one are obviously different. So I want to move this one up. Well, if I want to move it up, that means I have to add to it, which means to increase the y-intercept. Okay? Next, this one right here. If I draw a line of best fit that best represents these points, I'm going to draw something that looks a lot like that. Okay? So I'm drawing something that looks like that. What I'm going to do is I'm going to start off with the rate of change. What does rate of change mean? Slope. Well, this line I drew is way steeper than what it should be. So if I want to make a line flatter, I'm going to decrease the slope. Okay? The initial value, what does initial value stand for? Y-intercept. Well, y-intercept for this one is up farther, isn't it? So that means I want to increase the y-intercept. Okay? So, just a little something for you guys to look at. Alright guys, so let's go on to this one here. It's the last one we have to work on. So, when we're taking a look at this, it says draw a line that best represents a scatter plot. So, we're talking about this. Basically what we're trying to do here is we're trying to draw a line that best represents these points. Okay, best represents these points. So what you're looking for, you're kind of looking for something that has as many points on the line as possible, right? And again, about the same number above as below. So what I'm drawing is something that looks a little bit like that. Okay, all right. So we got a few above and a few below. Okay, but it basically represents that line. Now here's the thing. So it'd be really hard for us to use the calculator to do this because we really don't know exactly where some of those points are. So that's why we have something like this. Now to write the equation of the line, what are the two things you need to know? Slope and y-intercept. Okay? So for this one though, y-intercept we found is pretty easy. It's right there at 0.4. So that makes it pretty easy for us. Now, if we are going to try to find the slope, changing y over changing x. Now, there's different ways of doing this. You can use, see here, we kind of have a little slope here that's easy to use, but you do have 2 points on this line, right there. So what we can do is find our slope given those 2 points. So how many units up do we have to go? 1, 2, 3, 4, 5. 5 units up, okay? Then from here, how many units to the right do you have to go? If you start counting over, you'll count all the way over to 15. Well, 5 over 15 gives you a slope of 1/3. Okay? So, writing the equation of this line that best fits this is y is equal to 1/3 x plus 4. Now, you kind of have to play with it a little bit to try to find this. And again, when you're writing a line of best fit, you might have to erase. Okay? You're not always going to get it the very first time. Sometimes it takes a little while to get used to it. Okay? But that's what we're looking for. Alright, so with that done, let's move on to the last one. Now what I want to do is give you guys a second. I want you guys to practice 2 of these. So, given what you have right now, I want you guys to take these 2. I want you guys to plug the information into stat and edit. And I want you guys to get a slope, a y-intercept, an equation, and check the r value. Okay? So, if you would, press pause. Try the first one. Alright, so hopefully you have an answer. I'm going to show you what they should be. Okay? Alright, so hopefully that's what you got. Now the r squared we're not going to worry about as much right now, but just know where it's at. All right, so press pause again. Try the second practice problem. All right, so now let me give you the answers. Okay, so slope of -3/4. We get b is 23. There's your equation. Now as you look at these, one thing you should notice, the r value for the second problem, that's a pretty decent one. Okay, and that's a negative slope. This one's decreasing. You can even see that here. Okay, this one's also decreasing, but that r value, that is terrible. That is a pretty random set of numbers. This doesn't really represent a linear function very well. That's the best function we can get out of that. Okay, all right. Ladies and gentlemen, we will have an assignment tomorrow dealing with this. If you got any questions, let me know. I'll talk to you guys later.